Hello, everybody, dear participants in this webinar of the International Network of Salt-Affected Soils. We are grateful that you did your best trying to match your timetable to attend the webinar. This is usually a difficult point, trying to put together people from different longitudes. So thank you, all of you. And we organized this webinar around the concept of the soil health. That it is a concept that now it is discussed in several fora inside the FAO. Now there is a panel about discussing in general the ideas of soil health for the different kind of soils. But we are interested now in speaking about the soil health related to salt-affected soils that are, as you know, two groups of salt-affected soils, or those that are natural originated and are really fantastic environments where life has learned to adapt and that support high biodiversity. And by the other side, we have this degradation process that is the salinization that degrades the quality of the most input soils. I mean that cropping by irrigation, it needs of a high economical and effort input. And so the soils not always have the higher productivity possible. And if not well managed, they get degraded and they lost their favorable properties. And for developing this webinar, that we would like to present this as a roundtable. I mean, now on the screen we are in a square and in a matrix, but think about a roundtable, about the panelists. And also the participants can as well participate, making questions through the chat that will be collected by Maria Kuniaskova, and later will formulate it to the panelists in particular or in general. So all you participants are encouraged to actively participate. So for developing this webinar, I want to thank the panelists that accepted to develop and share their ideas about the topic, and allow me to introduce in short, because all of their curricula are long, and so we will exhaust all the available time for presenting them and reading the full curricula, so we will do that in short. And as I told first, this is a roundtable, so there is no starting and no end. And so there is all panelists are reputed scientists, and so we cannot make here some kind of order. So allow me to make this in a nice way, starting ladies first. So I will introduce Professora Elke Nollenmeyer. She is Professor of Soil Science and Soil Management in the Faculty of Agronomy, Universidad Nacional de La Pampa, Argentina. Her main interest is in research and extension related to sustainable management, soil quality, and health. She has participated in the development of recommendations for environmental policies related to the conservation of soils and the ecosystem services that derive from them. She currently belongs to the 4 per Mil initiative, whose objective is to prioritize the importance of soil for carbon sequestration and climate change mitigation. And she leads a group of young scientists to work on certification of carbon sequestration and sustainable soil management in agricultural soils. Currently, she is the chair of the Commission 2.5 of the International Union of Soil Sciences, and she recently organized the 7th Congress of the Argentinian Salinity Network and the 2nd Latin American Salinity Congress. She's author of more than 50 articles, books, chapters, and so on. Thank you. You are very welcome, Dr. Elke Nollenmeyer. Professor Dr. Miriam Ostinelli, you know she for sure because she is now the current chair of the Global Soil Laboratory Network, Glosoland. of the global soil partnerships. She's an agricultural engineer and worker for more than 30 years as a researcher at the National Institute of Agricultural Technology of Argentina, working especially on soil and water quality and soil management and conservation. She was representing INTA in national and international institutions as a technical expert on issues related to quality of results and quality of soils. She has also published as lead author or in collaboration with others, articles, book chapters, technical reports, standards, and dissemination and training materials. She has also been a professor of soil management and conservation at the Faculty of Agronomy of the University of Morón in Argentina for more than 15 years. Professor Ostinelli, you are welcome. Now allow me to introduce, I think that it is, for most of you, you know her very well, their first lady in the meeting, that is Dr. Maria Kuniuskova. As you know, she is the coordinator of the network at the Global Soil Partnership, and she is very active in promotion of the projection of the network. And I want as well to thank her for her presence here. She will act as a reporter of the findings of the webinar. Thank you. Professor Eduardo Constantini is the current president of the International Union of Soil Sciences. He's a senior researcher with a past as a research director at various research institutions and as a professor of pedology at the University of Siena, Italy. He's an agronomist with a specialization in pedology and has carried out over 40 years of research work in Europe, Asia, and Central and South America, leading international projects focused on soil conservation and other pedological themes. Recipient of the Normal Hudson Memorial Award of the World Association of Soil and Water Conservation and the Gerald Richter Award of the European Society for Soil Conservation. He is author of more than 380 scientific papers, books, and book chapters. Professor Constantini, you are welcome. Professor Sanjay Arora is presently working as principal soil scientist at ICAR Central Soil Salinity Research Institute in India. He had made significant scientific contributions in bioremediation and management of saline and sodic inland and coastal soils. He has developed innovative halophytic microbial formulations for bioremediation of salt-affected soils for enhancing crop productivity under salt stress, evolved agroforestry and multipurpose tree-based restoration of degraded salty lands. He has developed decision support systems for chemical reclamation of sodic soils like GIPCAL mobile application, and has modified and refined the laboratory protocol for estimating gypsum requirement for sodic soils. He has published 167 peer-reviewed research papers and technical articles, edited books, guided a good number of masters, and presently he is chief editor of journal Soil and Water Conservation, elected Councillor of World Association for Soil and Water Conservation, and elected Vice Chair of the Commission 3.6 of Salt-Affected Soils of the International Union of Salt-Affected Soil. Sorry, not salt-affected soil, International Union of Soil Science. Professor Sanjay Arora, you are welcome.
Thank you, thank you.
Professor Hasisha Mohamed is researcher at the INGREF, Institut National de Recherche Ingénierie Rurale, or FORE, Professor of Higher Agricultural Education. He is director of the Research Laboratory Valorization of Non-Conventional Waters. He has extensive experience in the coordination and management of research and development projects in the field of saline water and treated wastewater used in agriculture. He has coordinated several projects at national, bilateral, and multilateral levels, published more than 50 articles in national and international journals, and holds 2 national patents. He has published several documents, including guidelines for irrigation with salt water and has reviewed several articles for national and international journals, supervised students at degree and doctoral and master's, and as well participated in numerous courses, training in Arab and French-speaking countries. He has carried out several consultations for Tunisian and international consult firms and organizations. Professor Mohamed Hashisha, you are welcome. And at last but not least, Professor Fei Wang is Deputy Director of Institute of Soil and Water Conservation, Chinese Academy of Science and Ministry of Water Resources in China. His research interests are on sustainable land management, focusing on the environmental, economic, and social impacts of land degradation and restoration, assessment and designing locally sustainable technologies and approaches for soil land management and environmental policy development based on science and stakeholder provided. He is director of the Committee of Young Scientists, the Chinese Association of Soil and Water Conservation, co-chair and steering committee member of the DesertNet International, Professional Scholarity Excellence Finalist Award of the Process Subjects category winner award for environmental sciences in the 6th Global Environmental Outlook, expert of United Nations Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services, an expert of the United Nations Environmental Protection, the 6th Global Environmental Outlook. He has been involved in more than 20 international projects and has published more than 200 peer-reviewed articles. Professor Fei Wang, you are most welcome to the meeting. Excuse me, all of you, because for time requirement, we did a short of your impressive curricula, but I think that it is enough for the participants to get an idea of the quality and the vision of the panelists that participate here. I would like to start trying to make this as a round table, putting on the table two starting concepts that are, I think, the central concepts of the webinar. First is why are we speaking about soil health, and especially about soil health of salt-affected soils, and what is the meaning of the soil health, and why are we shifting from the paradigms. I should point out that we started with the soil classifications, and then the soil taxonomy in the 1975 was an important milestone because designated a classification based on numeric criteria and diagnostic properties and diagnostic horizons. So we studied the soil as its components in a very detailed way, and classification give 7 levels for classification of soils. Recently, the World Reference Basis has taken an approach close to this, not in the hierarchy, but as well in the horizons of diagnostic and properties. And so we have a very well sound scientifically based concepts about what is a soil and the components and the behavior of soils in local, in genesis, but soon after this classification of the soil taxonomy, they appear the concept of land capability, and notice that we shift from the concept of soil to the land. That is different, and especially FAO concept of land is more extensive, including people and other activities as well, and as well the land use and land capability. And in the 80s, it started the concept of soil quality, and then it was not so clear because it took a vision of the soil as servant of environmental services. and not taking into account what we learned about the horizons, but taking soil as a whole. And now we're speaking about the soil health, shifting from this other concept of soil quality. And it is, we cannot avoid the parallelism when speaking about soil health from human health. So we wonder what is the concept of soil health related to the salt-affected soils. And it will be great if you give some enlightening about this concept and how it is considered in the different fora and how it is applied, that because it is a kind of joke. Are these salt-affected soils ill? What medicine should we use for keeping them healthy? How can we keep track of the health of the soils along their life? So these two questions are on the floor, and you are free to take the floor for starting with the conversation. So up to you. So, Dr. Sanjay Arora, please go ahead.
Thank you, Professor George. Basically, soil health, which we understand, basically is the terminology which is used for the soils, especially because these soils are presumed to be live. Live means having life, and once the health deteriorates, we have certain indicators to assess the deterioration of the health. But in salt affected soil, these soils already are ill, as you have illustrated. These soils are basically ill and needs more liveliness in terms of biological, in terms of nutrients. So both these and aeration, as well as other factors, are dependent on biology of the soil. This was the basic thing which needs to be addressed, especially more stressful under these stress soil.
Thank you. It is nice if you take the floor in a fluid way. Yes, go ahead, Elke.
Okay, I slightly disagree. I think every soil which is in its natural habitat and in a landscape position where salinity is normal for this soil, I think we have a healthy soil for that position. So we can, I just would like to share the screen and show some pictures to clear this.
Yes, please.
Let's go. See, we, in our landscapes, we have lots of soils where we have a saline water table below it. This is just, the Pampas region is like that, and most of the soils in the depressions of this landscape are salt affected naturally, and then they look like this, the environments. We have borders of salty lagoons where we have a lot of vegetation. And if we analyze these soils, going back to the soil taxonomy, those are mostly mollysols. They have a very thick and dark A-horizon, lots of organic matter. And I would say they're perfectly healthy for what they can do, because we can't expect anything else in this kind of landscape. So while they're covered with this natural vegetation, which suppresses the ascending salts and maintains a full cover of vegetation all year round, a good input of organic matter. Most of them have extremely good structure in the A horizon. So we have habitat for the microorganisms, which are obviously adapted to the saline conditions, to the pH, etc., etc. So I would say this is an example of a healthy soil. This would be a natural qual or something similar to that. But then if we start to quit this natural vegetation cover and we start to cultivate these soils with corn, as you can see on the right-hand side, then salinity reaches the soil surface. The crops are not viable. We get lots of bare patches, and that obviously is not a healthy soil. So I think we have to be very careful when we talk about soil health, that we take into consideration which are the environmental condition of the soil we're talking about. When we talk about soil health, we always have to relate it to the ecosystem services soils can provide us. So a saline soil, naturally saline soil in one of these environments could provide very good ecosystem services to us. They might be the basis for extensive grazing. They harbor a lot of interesting, or in the future, even more interesting microorganisms. They serve as a buffer for saline seeping. So I'd say not all saline soils are ill. We make them ill if we don't respect the soil's vocation. We always say, in order to do the correct soil management and maintain ecosystem services and maintain the soil healthy, we have to adapt the management and adjust to the soil's conditions, which are naturally given. We call it the vocation of the soil. What can we do with the soil according to its vocation?
Thank you. Thank you for your point. Dr. Shanghai, go ahead, please.
I agree, but basically, if we talk about agricultural soils, where agriculture needs to be done and from which we want output for the farmers to cultivate and get good production. No doubt, in natural condition, these soils are virgin soils. They are less polluted. They have limited activity. But in agriculture, if there is presence of high concentration of salts, the halophilic organisms might be there, but they might not be much beneficial for agriculture production systems. As you correctly pointed out, that management need to be opted, and sometimes management options are either not very feasible in most of the areas where we recommend uh, leaching through good quality waters, and in saline conditions, if there is sandy soils or the light textured soils, where we see that the groundwater is also saline, and the availability of good quality waters makes them more ill. And similarly, scrapping or the other approaches which we are recommending for saline conditions uh, is a very costly affair for a marginal or a small farmers. On the other hand, in sodic conditions, the situation is more tough. The clay content, if the clay content is high, not only in alluvial conditions, but also in vertisols, If this situation is there, then leaching or say removing of salt beyond the root zone becomes more tedious. The management are tedious and it needs to be site specific. But if in general we talk about health uh, in terms of agriculture production, then there is limitation, I believe, in salt affected conditions.
Thank you. And well, I want to reiterate the question if it is possible to get an approach. What is the advantage of shifting to speak about soil health? We have soil quality in the past, and we have as well the soil classifications. So now we are approaching the soil on their behaviors, not on their nature. And it is clear that for humans, it could be very different, nature and behavior, and behavior can change. So I wonder if it is this concept of soil health should be refined or think it, or if it is strong or it is weak. What is your opinion, Elke, and later Constantino?
Yeah, and then Eduardo. Sorry, Eduardo. But I think soil health is, we understand it as analog to human health or any concept of health we have. So that means that we conceive the soil as a body, as a functioning body. And if this body is healthy, all the necessary functions will take place without any problem. Now, if the soil is sick, to say so, many of the functions won't work. And this is what we see. Sanjay, I agree with you. That's what we see in agricultural soils. There's no drainage, there's flooding because there's no infiltration, etc., etc. But I think the idea of taking this concept of soil health is very useful, because for common people who don't understand very much about what soil really is, it gives the idea that soil is not just an inert substrate for cultivating, but that soil is a living body. So from that point of view, I think it's very important to maintain this concept. But obviously, there's no clear definition, and there's a lot of discussion going on still on what we mean and how we could measure soil.
Thank you. Eduardo.
Yes, thank you. First of all, I want to say that for me, the concept of soil health is useful to convey the message to lay people. And I remind you that we used to talk about soil fertility when the main issue was food production. Then we moved to soil quality in parallel to air quality, water quality, as long as the citizens were concerned about the quality of the air and the water they drink. And so we started to talk about soil quality and to analyze soil pollution and everything related to the contamination of soil. Now we have introduced this new concept of soil health, as long as our research study has enlightened the role played by soil biology within soil. So as long as we have more tools to investigate what is going on within soil biology, as we are trying to make the most about soil health, but not only because of the study of on soil biology, but also because our environmental concerns. So we are aware that the soil provides not only food, but also many other ecosystem services. And so if we want to take into consideration the bulk of soil ecosystem services, we have to go beyond food production. We have to go beyond the quality of soil in terms of capacity of productive capacity, or even absence of pollutants. So we have to consider all the set of different ecosystem services. And this is rather demanding, because you know that there are some ecosystem services we can conflict one to each other, no? And if I'm allowed, I would also highlight some aspect related to what Elke called the vocation, or I would say suitability of soil, because in relation to soil salinity, we can also have some positive effect. So if I can, I would share my screen.
Yes, please.
Okay, I hope that you can see my screen. Can you?
Yes.
Okay. So
full screen, full screen.
In full screen. Okay.
Can you make
In presentation mode, please, if possible.
Is it? It isn't in presentation mode.
No, not yet.
You
Not
might
yet.
see it is in presentation mode. So I try to.
F5.
Sorry.
F5.
F5. I try to do this way. Does it work? No.
Well,
this
is not too important.
But I can try again in another
okay.
way. I can try again in another way. So I think that I have to. No, it doesn't work like that. Sorry, but okay.
Don't worry if you cannot in full mode present us as you did. Picture is big enough.
Oh, it's big enough. Okay, thank you. But yes, I don't know why, but I see the presentation in full screen mode, but
don't worry.
You can't. Anyway, so I just want to say that soil salinity stress can also be an ecosystem services, because we know that salinization causes a reduction in yield, but for several crops, a moderate degree of salt in soil can increase food quality. For instance, this is a picture I taken in southern Italy, where the production of this high quality tomato is widespread, and the size of the cherries is very small, but the taste is really wonderful. This is because of a particular condition where salinity is there, but is not so high. And the farmers have selected the right varieties for the right place to produce the best quality tomato. The same is true for other crops. For instance, also for grapevine. In this case, you have a reduction of the production, which increases the degree of sugar within the berries, and also the degree of alcohol in the case of wine grapes. But it is important that the salinization only affect the deeper part of the soil, like in the right-hand picture. If for excessive earth moving before the vine plantation, you let the saline horizon outcrop, then you have this left-hand picture where you have several vines dying, suffering too much and causing very unfavorable condition for the grape production. So it is really up to us how to modify the environment. I remind you that we are in the Anthropocene epoch. There is someone who talk about pedocene in terms of the effect caused by man on the global soil resources. I remind you that more than half of the soil at the global scale are more or less affected by man. So we have to consider very much what is our use and management of soil. And we have also to take into consideration other factors like climate change, but also broad phenomena. This is an extract of the map produced by the Global Soil Partnership about saline soil all over the world. This is of Italy, as you can see. On the right-hand side, you can see the soil salinity in depth, and on the left-hand side, the soil salinity on surface. Actually, luckily, we don't have severe or very strongly saline condition rather frequent in Italy, only in some part of Italy. But as you can see, there is a large diffusion of slightly saline soil, which is very little saline soil, but rather widespread. And what is really striking is that they are more widespread on the surface rather than in depth. This can be caused by the use of saline water, but actually this is common not only in the plains, but also on the hills, on the mountains, under forest sand. And so I think this is a clear sign of what we know it is the role played by Saharan dust deposition. So we have an estimated amount of deposited Saharan dust in between 3 and 5 grams per square meter by year. And I think that this is a clear sign of this replenishment of a basis of slightly calcareous material or saline materials which come from the Sahara to Europe. This is very important because this is a resource that we are using for natural fertilization, natural improvement of soil quality and soil health, at least in Southern Europe, but I bet that this is a common feature also elsewhere. Yes, this is just the announcement I want to do about the centennial of the INSAS, which is going to take place next year in Italy. So thank you.
Thank you, Eduardo. As far as, if I well understood you, you tell us that soil health concept is a natural consequence of the evolution from soil quality because of the introduction of biology considerations of the soil and so on. Is this more or less approximate?
Yes, you are correct. I think that the terminology changed over the year according to our research studies. So our concepts are developing according to what we can understand about the soil system. And yes, I do believe that soil is a self-organizing body. And you possibly know that the first soils on Earth were green or blue in color because there wasn't any oxygen in the atmosphere. But then the soil changed in color, and possibly the soil of the future will be all red, like in Mars, you know, in the planet Mars, because there everything is has been very much oxidized. So the soil systems are evolving during geological time. Now we are entered in the Anthropocene. And so the human effect on soil is very much important. And we have to rule this effect if we want to keep the soil healthy.
Thank you very much. Miriam, please go ahead.
Yes, thanks, Jorge. I think first I agree with Elke and Eduardo and the colleagues on the concepts, but I think that the concept of health help us think that we must include not only the genetic characteristic of the soil, but also the result of the management we do of that soils. Because I agree, the soil is a result, the health soils is a result of the environment and of the we do with the soils. So from the labs, I work at Glosoland. Of course, I have a point of view from the lab, but we use the indicators to guide us about the health of the soil, but we need to think about the soil in its environment. I think I agree with that.
Thank you. The point is that soil salinity, well, it is an adverse condition in agricultural soils, but there are illness. There is influenza. After 7 days, it comes quickly with one irrigation, and maybe this get out after important rainfall. But there are other considerations. I think that because with salt-affected soils, I ask about your opinion. The status and the time of measurement it is important, and maybe not in one moment to check this about the salinity, because it's transient condition all time, all year long. What is your idea? How should we approach to that? Should we imagine that we go and measure in the rain season, and then so on the root zone there is quite no salinity because it was leached down, and so we think that the soil is. But if we go in the evaporation season, then problems are evident. So should we try to make this and the indicators and more dynamic and telling the difference in between rain and humid and dry season or things like that? I have no clear idea. I would like to hear Elke, please.
Yeah, I think we have to do a more systematic approach to this. If soils are saline, the source of salt is somewhere around. So the idea, I think, is to identify where these salts come from. This might be from irrigation waters, or it might be from the water table. So I think the best idea to monitor and to predict what is going to happen with the soil is to firstly think, okay, in this soil, what might be a possible source of salts, and then go and check where this soil might become, or why, and due to which factor the soil might become saline. So check the water table, what kind of quality of groundwater do we have, how near is this water table to the surface, how the soil conditions favor saline seeping or saline ascents to the surface, etc. Or is this soil under irrigation? So check the water we use for irrigation.
It is interesting because you introduce another point that it is not the status, it is the risk as well. So thank you. Dr. Shanghai. Go ahead, Shanghai.
Yeah, I agree with the Professor Eduardo regarding the ecosystem services with these soils we are concerned about. But in many of the saline and sodic areas, God has gifted in nature. We see there is natural vegetation. There is means in saline condition also, as well as in sodic condition. But these soils are not economically useful for the owner of the land. Especially in terms of community lands, it is okay. It provides the different services, and especially in India, we can see in the nearby the railway track or in the community lands in the village, means in the villages, there is a land owned by the social forestry departments that can be under. We are not concerned much about addressing that in terms of the soil's health. And if the soil health indicators we see in most of the research which we are doing, and we are following the indicators of the normal soil, where we miss the some of the indicators which especially are related to soil biological health, as well as soil, as you rightly said, Professor George, the infiltration or the physical characters in which these soils are very poor. So that needs to be addressed, or means included in the saline soil. It should be a different set of indicators, and for sodic condition, it should be different set of indicators. And as Professor LK pointed out, that means we have to see from where the salt has come. In many of the canal command areas, the seepage from the canal results in salinity. The groundwater is also influenced by the long time seepage. So that needs to be included as one of the indicators for assessment of soil health in salt affected soil.
Thank you. Interesting. You introduced one of the important points here today. It is the indicators. And if the indicators, we think that we should speak about this, the indicators on the soil. But if we go to the management, there are other frameworks that maybe can be considered. Thank you. Eduardo, please.
Yes, just a brief comment on your stimulation about soil monitoring, about soil salt condition. You are perfectly right. Soil salinity can be transient phenomenon. So that means that you can spot in a season, but not in another. It can be incipient phenomenon. So you have to have early warning system and indicators to detect the signs of incipient salinization. Nowadays, we rely not only upon wet chemistry, but also on censoring, proximal sensor, remote sensor, modeling. So we have plenty of tools to use to recognize incipient or transient salinization. But what I want to stress that it is the importance to go into the field, to dig a soil profile, to carefully observe soil orientation, soil structure in particular, because soil features, because even if you don't have a chemical sign of salinity, but from the observation of the structure of pedological features, you can see really what's going on in a longer time, because we as a soil scientist has the ability to understand not only what is going on in the soil right now, but what happened in the past and what's going to happen in the future. So I think that this expertise must be valorized.
I agree, and allow me to remind words from the late Professor Van Savold. One cannot be a doctor if don't know about anatomy. So, Elke, please go ahead.
Yeah, I completely agree with Eduardo. Sorry. Yeah, we actually, and this is, I think, a bit of training that has to be done. We actually devised or we published a handbook for visual soil evaluation, which includes saline soils, because we have lots of them around here. And the idea is to visually appreciate signs of problems of potential salinization, as Eduardo pointed out. In the soil profile, we can detect accumulation of salts. Specifically, we have to be very careful to kind of detect the difference that exists between very soluble salts or less soluble salts, because the very soluble salts are easy to detect by anybody because they appear at the soil surface in any moment. So anybody can see the white salt in the soil surface and is aware that we have a problem here. But many water table quality is characterized by very low solubility salts. And what these salts produce in the soil profile, once the protecting vegetation is removed and we pass these salts to agriculture, is that we get calcium carbonate hard pans within the profile. So what happens? Infiltration will be even worse. The soil structure will be worse. We'll have flooding. So my recommendation is, in agreement with Eduardo, we have to have a visual evaluation of the soil profile and then take into account what kind of salts are present. Because low solubility calcium carbonates, bicarbonates are very, very difficult to remove from the soil profile. As we said, soluble salts are washed away by the next rain, and they're easily washed by a correct drainage and irrigation system. But once you have an accumulation of calcium carbonate in the profile, it's very difficult to change these new soil properties, and this soil will be very prone to flooding and other problems.
Allow me to make a joke to tell about my idea of about it is connected with measuring and monitoring. Two friends go for a celebration. One is a habitual, a permanent drinker of alcohol and has liver destroyed, but this they did not drink. And the other friend, he was a healthy sportsman, but this they took 2 or 3 martinis, and then driving, police stop, and then make blood analysis, and who had the penalty, and who. There's this transient moment, and not the other, that the accumulated effect has destroyed the liver. And we usually think that we measure electrical conductivity of the paste and this give actual equilibrium, but not usually. It is perform an analysis of the amount of soils stored in the soil and how long it will take to recover. What do you think, Miriam? Miriam, the floor is
Yes, yes. Okay, I agree. I agree that you have some indicators, some parameters. You need to see that, but the amount of salts or and the condition of the soil, it could be different. Different in the time of your measurement or in the sample you take, you need to see the profile. You need to monitoring the situation in different times. So you need to know the system. Because only with the results of the data of the laboratory it's not enough. You need to know the system. You could you could product some crops and or some type of production, but you need to know the system. I agree with you. The data is very important, but in a framework where you know the system.
I take the occasion to invite you, as well I will do with the chair of INSOP, to develop a webinar on the purpose of sampling and the approaches. In this way, we announced this as well to the network members of INSAS. Shanghai, go ahead, please.
So there is a saying that you cannot judge the intelligence on the basis of the clothing, the attire. So similarly, on basis of simple physical judgment, physical analysis sometimes misguides. And before arriving for any management option, extensive analysis needs to be done in the laboratory. The uniformity of the methodology to be adopted for saline and sodic condition globally needs to be addressed by the INSAS, especially because earlier in most of the countries USDA or a single set of protocols were being followed. And if we are going to judge the soil health on the basis of certain indicators, and in which we want to include the salinity or sodicity indicators, especially SAR, ESP, pH, EC, the uniformity needs to be done, as Maria has already circulated questionnaire, and we see that there was distinction among the countries regarding the analysis or your protocols being followed. And in that case, some of the indicators we can miss. Otherwise, uniform indicators can only be followed or adopted if globally there is a set of manual having set of these protocols. On that basis, soil health can be judged.
Yeah. And so all you highlight the importance of the management and the waters and the climate and all environmental conditions. So I'm sure that you know the procedures of the this kind of methodology that comes from the environmental impact assessment, that is the drivers of degradation that determine pressures that affect the state and then make impact, and then how it is the response. And so this approach takes into account not only the soil conditions, but as well water, the human demand, and many other aspects, social, economic, and so on. And these systems rely on the existence of indicators, appropriate indicators, and indicators for the status that we are speaking mainly when we speak about salt-affected soils are very important. And I wonder if we should agree that the indicators of soil health for salt-affected soils should be quite different from other kinds of soils and adapted, and to be more dynamic than other for other soils. For example, maybe I'm wrong, but the carbon stabilized carbon content do not change so quickly as salinity in a soil. So the indicators for our kind of soils, I wonder if you agree that should be more dynamic, and if you agree, how we can do that. And apart of that, should we think about the elaboration of indicators as well for pressures and the impacts and that are close to the system, but not only soil? What do you think? So I refer to the elaboration of indicators for the salt-affected soils, in particular, introducing the dynamics of the conditions, and going beyond this classical that we use as a rule of thumb since the 50s, and as well to extend that to the pressures and maybe taking into account the risks, as LK and for example, highlighted by the use of low quality waters. And by the way, I wonder, we are increasingly using reused waters, and we in Europe, we use recycled water from the cities. And there are emerging pollutants that are, for example, medicaments and others. And if we use this water for irrigation, what could be the impact? And remember that the salt-affected soils need this of agricultural exploitation. They need about irrigation. What is the forecast of what could be the impact on soil biology and then soil health? Dr. Van Fey and Dr. Hashisha, you are invited to warm up the discussion.
Okay, I can speak.
Yes, please.
Okay, first I want to make, there is a difference between soil health and soil quality. Probably soil quality is used for agronomic purpose, and soil health is more general. The second, I think the soil quality is must be a relative word or concept. Also, there are difference between concept and paradigm. Paradigm is another form of to see the problem and to see different problem. The relative the word health quality of soil must be different from country to each country. For example, what means good soil, good quality of soil in a country affected by desertification, with the other country not concerned. And I think each country or each region in the world, in North Africa, maybe Mediterranean region, must have a form or a concept of soil quality. I think also the problem of salinity must be as dramatic as we try to see. We must have a positive form of view of the soil affected by salinity, and we compare salt affected soil to desertic soil. Soil affected by salinity is better to desertic soils, certainly. Concerning my country, Tunisia, we are probably leader in the world, because we have percent of our soil affected by salinity, primary salinity, and more than 50% of our irrigated soil affected by salinity, and also irrigation water is very bad quality, and 20% of the the water affected by salinity. I think we need to have a relative concept of course soil quality from time and space. The situation now is not so bad as in the past because there are innovation in technology. We control more. And my talk, if you want to present my speech, it's the more concerned by the system soil, water, soil, and plant. And some solution that me and with my team try to propose to the farmer, to the stakeholder, to use better the soil affected by salinity in irrigated area. I can?
Yes, please.
Okay. It's okay?
Now, yes.
I can?
Yes, yes, please. If it is possible, yes, no, correct. Thank you.
Okay. I propose some adapted solution to climate change because the situation, I think it's better now than in the past according to the problem of climate change, and to use the brackish saline water and salt affected soil. I am in my lab, we work also on the use of treated wastewater and the sludge also, but I will go to focus on some result that we obtained in me and our team, and to improve the soil affected by salinity and irrigation. The challenge, Tunisia, I think, but also in some other countries, North Africa in particular, and MENA region, is the resilience to water scarcity. The problem of water is not new, but there are a degradation of the quality, and now the problem that I think anybody from our colleagues speak about the problem of climate change that will go to induce more problem. I have two aspects that I will go to develop because we have a short time, 5-7 minutes.
Yes,
how
please.
we can improve salinity management at the parcel level, at the farmer scale, and how we can monitoring soil salinity and predicting the risk of groundwater salinity. Because the problem in the future that we'll go to have transfer of salt to the groundwater, and we will go to probably use more saline water for irrigation, this according to the climate change. For the improved salinity, there are different forms that our team in our lab developed. All of them are published in impacted paper. First, I think we need to improve irrigation efficiency, irrigation water. When I speak about water, it's brackish or saline water, and the drip irrigation, subsurface drip irrigation, but also subsurface drip irrigation can't improve that. And you see in your right that we can improve by subsurface drip irrigation because we'll go to reduce the water stress and the saline stress. This is the example of tomato, and there are an increase of the yield of tomato. The other solution that we use, and there are different forms in different cases in the world, we use alternative crop, more adapted variety, or some in saline condition, and this is reduce the problem of salinity now and the future in the biotechnology. We began to use, for example, olive trees more adapted to salinity. Some of them from Spain, Arbequina. Quinoa is pseudo cereal from South of America, more adapted to high condition of salinity and also water stress. Hispania also from Senegal is the first. Aloe vera, the cosmetic plant that we propose different form of plant. And the farmer, according to the condition, economic condition, social condition, market, he adopted the crop more adapted to his condition. We can improve crop salinity tolerance by organic substance, proline, but there are many other substances. I think our colleague from India and Pakistan had a lot of activity according to this. And we can improve this is the figure, the yield using this organic substance. It's not it's organic, donc no problem about the residue. Now we began to use some form to improve water quality. There are reverse osmosis, nanofiltration, ultrafiltration, the membrane treatment, and also the electromagnetic and magnetic devices can also reduce around 30% of the salinity. If you irrigate it with 6 grams, it's up like 4 grams. It's not the complete solution for salinity, but that reduce the problem. And now, according to the innovation and technology, EOT and remote artificial intelligence, we can also control the irrigation, the frequency of water, the dose of irrigation, and to improve water management. If we improve water management, we save water, and if we save water, also we reduce the problem of salinity, and we use it different form of that. I will go to finish the second aspect. This is the problem of climate change, and we want climate change. There are two problems. Increase of temperature that affect the evaporation, but we'll go to have more and more extreme event of rain, and this is extreme event can improve the leaching of salinity leaching, but it's not exactly a good aspect if we see the problem of transfer of salt to the aquifer in the future. In the Underwick system, like we have in Tunisia and probably some other countries, we'll go to have and modeling use model IDs or flow, mud flow. There are different models. We can see this is some figure the effect of some heavy rain to transfer the salinity in deep, and also to see the under climate change for the future, for 20 years in the future, if we'll go to have a transfer of salt to the aquifer, and what solution we need to prepare for sustainable agriculture. This is my research gate, and this is my contribution in the seminar. Okay.
Thank you very much. And Dr. Onfei, we did not have the opportunity to hear your voice here. Now it is good time if you agree.
Yeah, yes. Good morning, everyone. Indeed, it is
first, thank you very much, because it is midnight for you. So
yes.
Our apologies to you and your family.
Thank you. But I'm very glad to be here to share some idea on the health of salt affected soil, and I'm really agree to some ideas from Adaldo, like sometimes salt affected soil has some positive impacts. It's really very good, because indeed in our world there are three great area of salted soil. They must have their own special functions. We must accept this idea, and also I think the health of soil need a very good indicator system. But for me, I'd like to suggest if we want to describe the health of salt effect soil, it'll be much better to describe at a different level, at least 3 aspects. The first one is we should describe the soil quality, like physical, chemical, and biological parameters of soil, and especially the salt effect soil. It's a little bit duplicate to describe the soil itself, but it's very important to know the character or inherence of soil. This is the first level. And the second level is we should think about the function of soil. Like in some place, we should think about the diversity of landscape. For natural landscape, the salted soil maybe have some different functions. But if we consider it the function for crops or economic aspects, we should consider it some other indicator. And this is the second level. And the third level is to think about the environmental impact, all the impacts to environment and water resources, because salt effect salinity is very close relating to the water. Maria, can you share my presentation? I'd like to just yes, thank you. And I'd like to talk the functional oriented health of salt effect soil. Next one. Indeed, such soil is a very important kind of natural or human-induced of soil resources to maintain the functions of the different landscape. They have their special function for the whole ecosystem, and the functions of the soil is in the next one, please. Yes, thank you. Yeah, it's in different ecosystems, the soil function could be different. We cannot just consider it's for the crops or the productivity. We should consider its function for the different systems. And this one is to show the environmental impacts. We should not think about the function for crops or plants. We also need to think about its offsite impacts of salt effect soil. Like this, where is the salts go to? Cropland nearby, urban area, upstream or river, and remote place and our lands. If we think about such offsite impacts, we must can get a different view to the salinization. And next one, please. Maria, next one. Okay, and indeed, worldwide, a lot of crops or plants and local animals have already agreed with their condition. For example, in China, in Ningxia province, we have a kind of very good sheep, and the motto is very good, just because the sheep grows on the salt effect crop, the land. They drink salted water, and they grow not so fast, but the meat is very delicious. And also, we should think about the balance of salt. For example, if the 3 gram per kilogram is tolerable, but if we want to get more products from the saline soil, we need use more water, and a lot of water is just for the balance. It's useless. Indeed, it will make the water shortage condition worse and worse. And the last one, please. Okay, sorry. And okay, like the soil with less salts is more healthier. We like to put forward the double desalination approach to get rid of the soil from salt from soil with water, and then use desalination to get the salts from the water. So the soil will leave the ecosystem for a long time. It will be much better. Thank you.
Thank you very much, Dr. Weifeng, for your point. And now I wonder if there is any comment, or Maria, are there questions from the participants?
Yeah, so actually there is I would say, a very active discussion about the soil health concept in the chat. So there are many different opinions, but I would say that they are more or less in the same line that you were discussing, that actually, and also the question which I would like to address to the whole panel is that, so what is the difference between soil health approach or concept and the sustainable soil management? So, and I think that also discussion was about that if we consider different indicators, we can treat soil as if it is not healthy, but it is, because the management can be fine, so the everything can be going well in this given environment, and in this let's say all the properties that we have of the water, climate, and etc. And so the question is that what is the difference between soil management and soil health as a new concept? So maybe to sum up briefly.
I will explain you the first. Maria, sustainable management is what I do with my health, but you that are younger and are not so concerned with that. So just kidding.
Yeah, but we both can hold a healthy lifestyle. So in this case, can we consider both as healthy? So if you follow the healthy and sustainable soil management, so this is the way of discussion, let's say.
Elke, please.
Yeah. It's the healthy lifestyle for soils. And what is a healthy lifestyle for soils? We can't say it in a general way, because if you go to your doctor and you ask him, what is a healthy lifestyle for everybody? And he'll say, oh, that differs a lot among the persons. So sustainable soil management is depending on soil characteristics. And we come back to what we said before. We have to know our soils. this is a bit, I saw quite a few of these questions, and I think we are still too much focused on numbers. I think we have to go back to some very, very basic stuff as knowing or learning to evaluate soils from a visual point of view. An agronomist should be able to detect the state of the soil by a visual evaluation. Then some data will obviously be very useful to confirm my preliminary diagnosis, as to put it in a medical way. But you go to a doctor, he looks at you, he sort of takes in a lot of your symptoms or characteristics. If we want to design a really sustainable soil management for any soil, not only saline soil, we have to know the soil. And then we can use some selected parameters that we consider useful to confirm our diagnosis, to confirm the management plan. But there's no universal. There are universal principles, but the universal principles are these. Each soil has to be managed according to its characteristics.
Thank you, Eduardo.
Yes, thank you. Maybe you know that in Europe, a regulation has been passed by the European Parliament this July about the so-called soil health monitoring law. And there is this big attempt to have a monitoring system within the European countries about soil health condition. And there is a list of indicators. It is interesting to understand that some of them will be common all over Europe. Some other will be tailored according to national but also regional condition. And as a whole, they will be adjusted according to district, so-called soil district, where you have a certain degree of uniformity in soil condition, but also climatic condition and also agronomic condition, so use and management conditions. So this goes along what we have said previously. And in general terms, I think that as long as we go toward the soil health concept, which encompasses not only soil ecosystem services related to food production, but also other soil ecosystem services. We have to take into account the fact that we cannot rely only on few indicators, only on few traditional indicators. We have the need to combine old indicators with new indicators, possibly coming from research, and adapting these indicators to local condition and to our aim, because we have to also cope with the need of the humanity. You know that we are going to increase the population needs, and so we have also to rely upon soil which are not in perfect health condition to produce food, because as you know, we all know that it is very unhealthy to pay much time in front of a computer like we are doing right now. So, but we have to do that. So we have to find a right compromise in between the healthy and the sustainable soil management and the needs of humanity. Thank you.
Thank you. And expanding your information, I just have received an urgent email from the Spanish Society of Soil Science referring to the European Soil Monitoring Law, that it is still not finished, not complete, and asking about particularities and ideas from every of the countries. And so I think that it could be good if we can take some of the ideas from here dealing with the salt-affected soils management. And moreover, maybe you are not familiar in general, because we have here people from any longitude of the globe, and but Europe has approved as well, and to be developed, the law of restoration of nature. And this is amazing law, because it is promised that for the 2050, 30% of the degraded lands in the European Union territory will be restored. And for example, we have a lot of examples here of wetlands with high biodiversity that were, in the times of scarcity of food, were transformed to agricultural fields and with irrigation, and the horses that most of them were fed with brackish water and now are not very productive. So the indicators that are very important for the decision makers. And there is another complexity, that is that decision makers do not want indicators. They want indexes. I mean, they took several indicators and make such a kind of mixing and get one number. And with this number, they take decisions, and that's crazy, in my opinion. And so I'm in a group of the FAO and Global Soil Partnership and intergovernmental technical panels of soil, working on soil health indicators. And I would like to take your opinions and experience for making the difference for salt-affected soils, and try to, make evident that indexes cannot be applied for any kind of soils, maybe that for soils that have homogeneous problems or risk to be degraded, but some kind of differentiation should be done for such kind of special soils that as salt-affected soils are. And before giving you the floor, Sanjay, I would like to invite you as an extension of this meeting, trying to elaborate some sort of document dealing with these indicators for salt-affected soils, and maybe with a widened scheme of the environmental impact, dealing with other aspects as well. Thank you, and sorry for taking time from you, Miriam. Miriam, the floor is yours. Yes.
Yes, thanks, Jorge. Yes, I agree with your opinions, and about the indicators. As I said, from Glossoland, we are working on the different indicators. We are working in joint working groups with INSAS, and of course, we provide indicators from laboratories, from data, but as we are discussing here, we need to see other indicators about the physical condition of the soils, about the environment of the soil, etc. If you let me, I want to show some.
Yes, please.
Only one slide to show what are doing. Can you see my screen? Well, now I pass this because we are talking about that. This is Glossoland. We operate at all levels: global, regional, and national level to create and support soil laboratories capacities and achieve uniformity and quality in analytical results. And we are working with the other GSP technical networks and other FAO initiatives. In this moment, I can show you about the work we are doing with INSAS. We are working in showing working groups to elaborate, to prepare SOPs, harmonized protocols about different methods. INSAS help us with these protocols: soil pH, soil electrical conductivity, saturation paste and extracts, and other SOPs like boron by hot water extraction methods. And here I list some of the indicators we are working. Of course, in the framework you are discussing, we are discussing in this round table. And here I can show some of the SOPs we have been working, and they are available for free for all the labs or the public in general. So I only have this conclusion: the development of a set of indicators to describe the dynamics of the health of salt-affected soils is essential for the implementation of sustainable management practices on this type of soils, and for making decisions based on reliable and comparable information. Soil analysis laboratories are fundamental actors in the development of this process, and therefore Glossoland supports laboratories in improving their capabilities, training their staff, and ensuring the production of high quality soil data. And of course, Glossoland works jointly with other GSP initiatives such as INSAS through joint working group to develop soil health indicators and for the implementation of the different initiatives proposed to address threat to the soils. Only to share with you some of the work we are doing. And of course, I agree with all we are discussing in this roundtable about the indicators or the dates of the labs. Not is the only tools we have. We need to see the soil. We need to see the landscape. We need to know the environment, and we decide with all these tools. Thank you, Jorge.
Thank you, Miriam. And that's why we at INSAS will design a webinar dealing with the purpose of sampling and adapted to salt-affected soils in this case. And we will be glad to invite you or to the person that you will designate for helping us in the development of this webinar. And I will invite as well to another network in SOP to develop that. And this will be soon. And Dr. Shanghai.
All the panelists, including yourselves, have accepted that we should have a set of indicators. The set of indicators on the basis of soil analysis is one part, the climatic variables and the water quality, the other variables. If we are not going to integrate these indicators to arrive to a certain recommendation, which is possible as per our previous studies on soil quality or say soil fertility. In India, we are since 2015 we are having soil health card scheme by government, where the each farmer gets the soil health card, having 12 set of indicators that is common for every landscape system. Means in the coastal area also, in the inland also, and in the hilly regions also, in arid as well as semi-arid conditions. But it doesn't include the salinity or sodicity indicators. So if you allow me to share, I will just show you the indexing which we have done in the form of clubbing the indicators for soil assessment in sodic conditions.
Yes,
can I do?
Yes, we are beyond the schedule, but in the meanwhile that people is interested and time is available, we can do. Yes, please, not to be too long, please.
Okay.
We need some music background for this.
Okay. I will not go in much detail, but as I already emphasized on the uniform assessment of the BNEED set protocol, standardized for all over the globe, then just this is the soil quality assessment tool which we have developed in the form of software, where we are including not only the soil parameters but also the climatic variables as well as the water and the vegetation which have vegetation is also an indicator of salinity and sodicity, and that has been included to arrive to a the state of the soil quality. On similar basis, we can assess for the soil health. And this is the software application as well as the mobile application which we are disseminating to the stakeholders.
Thank you very much. Share the link for that if possible.
Okay.
And still 200 participants, and we are 1/4 hour beyond the schedule. But Maria, I know that you were very busy watching the chat and doing other tasks. Did you have the opportunity to get some distilled ideas of this meeting, or could you please present this to us?
Yeah, so
and with more available time, maybe you can prepare such a small written document. But by now, please.
Yeah, so I was watching the Q&A chat and the general chat, so trying to extract, let's say, the ideas that were shared both in the panel and in the audience. So I would say that in general, what we all agree is that salt-affected soils have value, and they have a right to exist. So this is the general agreement among all of us, and that these soils can have a positive effect. So we can also value that those functions that they perform, and that we also have to keep in mind that soil has many functions, not only the crop production, and if we consider the whole set of the aspects that soil has. So in this case, salt-affected soils occupy quite a, let's say, substantial part of the environment, of soil health, soil functions, etc. So this is agreed from all. From the other side, so salt-affected soils, and also we all agree, salt-affected soils are not that very much beneficial for crop production. So it's some sort of a obstacle of a barrier, or that we should find a way how to overcome, how to adapt, etc., etc. And so the people who work with salt-affected soils, in the chat, they raise the question, so what can we do? Okay, they are so good, but still we have to deal with them. And so, but still there is the common decision, common understanding that this soil should be treated with all the adaptation approach. So the irrigation system should be adapted, crops should be adapted, water management should be adapted. And so in general, it can be unified in the concept of saline agriculture, which is quite novel. It appeared several decades ago, but now it is raising up this idea that the saline agriculture is some sort of adaptation of humanity to salt-affected soils, trying to perform crop production on these, let's say, specific environments. Then regarding the soil health, I understand from the panel and from the chat that this concept is still very arguable. There are many different ways of understanding of this concept, and still there is no agreement about the what is soil health and how can we treat soil having this concept, let's say, in mind. So then the sustainable soil management is the key, so we agree, and that soil and environment, they should be considered, they cannot be considered separately. So if we want to discuss the soil health, so we should always keep in mind that soil cannot be taken by separately from the environment. So if we want to develop the indicators, so we should always take into account the environment in which this soil exists. Then regarding indicators, we are coming to quite tough set of these discussions and let's say arguments, that there is no agreement at all regarding indicators, because from one side, panel or people in the audience, they say that indicators should be they should exist. They are very much demanded. From one side, they should be specific to salt-affected soils, but from the other side, they should be uniform. This is the contradictory decision that we have from today's discussion. But let's say the way how to canalize this discussion is that, okay, we should have some key indicators. They should exist and they should be developed. They should be environment and soil dependent as well as aim dependent. What is the goal? And then we should develop, so we should sit together and develop harmonized protocols at the global level so that we can still develop the indicators, having this contradictory approach, that they should be SAS dependent and uniform at the same time. So this is my summary in general. So I hope I didn't forget something. So
thank you very much, Maria. Nice, excellent task. And well, I should say that we have a working group in the INSAS that deals with indicators. So the members of this working group or other specialists are invited to exchange ideas, and I will invite the panelists of today to try to go a bit in depth in the aspect of these indicators that we agree that should be dynamic and, well, several special characteristics because of the nature of salt-affected soils. And it is because soon, it is not scheduled, but soon we will have another meeting of this working group with indicators in general. And I will not like that this will be raw from our side, but a bit more elaborated, because these indicators for salt-affected soils will be mixed with other indicators. And I will try to keep sound that not please don't use such indexes, making a mixture of everything, but trying to to apply different even indicators for different kinds of soils or something like that. So I invite you all. I will write you for having some exchange of ideas with the seed of this webinar today. And thank you very much to all attendants that were numerous, and still a few number of them remaining. And thank you all very much, dear panelists, because of your willingness to share your deep knowledge. And it is only because of my poor skill to conduct the discussion that we did not get the most of you. Thank you very much, all of you, and see you soon.
Thank you. Thank you.
Thank you very
Thank you.
much.
Thank you everyone
Bye.
for
Bye.
giving
Bye.
the
Bye-bye.
Bye.
Bye-bye.
See you.
Thank you.
Bye-bye.
Bye-bye.
bye.
Thank you.
Good night.
Thank you. Bye.